so here is a little bit harder because this is a rational function. It's a little bit more involved, but we still need to do the same thing. We need to solve for the zeros, okay, at x equals 0. Now we have to worry about asymptotes. So I know I have a horizontal asymptote. As x gets really large, my horizontal asymptote is a limit as x goes to infinity of x squared over x squared minus 1. That's going to be equal to 1. And actually, for both positive and negatives, it's going to have the same horizontal asymptote. We have vertical asymptotes at -1 and +1. Okay, those are my vertical asymptotes. So my vertical asymptotes are at x equals plus minus 1. Okay, I better put my 0 in here. Okay, so those are things I've already kind of know about in this graph. I could put a y-intercept in here. Okay, y-intercept is going to be 0, but that's already been established. Okay, so let's add the calculus part in here. Max mins through my derivatives. My derivative is going to be differentiate. I need to use quotient rule. Okay, so there's my derivative. Okay, I'm going to simplify this. 2x squared minus x minus, and this is going to be it's going to be 2x cubed minus 2x cubed. Okay, so those are going to cancel out, so I'm just going to be ending up with negative 2x over x squared minus 1 squared. Okay, so it's equal to 0 at x equals 0. Okay, so it looks like I have a maximum or minimum there. I better test my slope there at 0. On the left side, it's going to be negative x. So negative is positive. The denominator is positive. So I know it's sloping up. So it looks like it's a max point. Okay, so if I plug in my negative, my positive, I'm going to get negative slope. Yeah, so that's a max point. So I know it's going to follow the graph. That's the max point there. Okay, so it says, oh, in this case here, it doesn't ask for a second derivative. Although I suppose I can do a second derivative, but it doesn't look like there's going to be an inflection point here, because we kind of know what this graph looks like. We know it follows the asymptotes here. Okay, so it's going to follow the asymptotes like that. Okay, it's going to go sloping up, sloping down. Okay, and it's sloping down. It's going to follow the asymptote like that. Okay, so there's my graph.